The other construct that we also dealt with was weights and pulleys connected by ropes. So we talked about this example where you have a ledge, you have a mass here, you have a pulley here, and it's connected by a rope to this mass. We'll call this one M1 and this one M2. And if this is frictionless, if this were a video and you hit pause, but then you hit play, you'd go over the edge. And if this tension stays taut the whole time, okay, which is what we are assuming, then there's some special things to think about for this. The tension, as I mentioned in class last time, the tension in all parts of a rope are the same. Even if this is broken by a pulley, the tension here is equal to the tension here. Okay? And if we wanted to analyze the movement, and we had that tension being there, and the rope therefore being taut, as these two move, they're moving together. They're moving in concert. So they actually are going to be experiencing the same acceleration. So if we wanted to figure out what actually is happening here, of course we'd analyze the free body diagrams for these things. And if we look at the second mass here, we have the force of gravity pulling it down. We have the tension pulling it up, and that's all we have. So Newton tells us to take the sum of the forces and set them equal to mass times the acceleration of the object. So right now we're looking at M2, so the forces acting on box 2 is equal to block 2's mass times the acceleration. The acceleration, we said, is going to be the same for both. So I'm just going to call it A instead of calling it A2 and A1 because they're going to be equal. Okay. The forces that are involved are the tension and the gravitational force on F2, put that at 2 there, okay, is equal to M2 times A. Now let's put in the directions. The tension force is up, that's positive. The weight force is down, minus M2G. And the resulting acceleration is also going to be down. So it's got to be negative M2 times the acceleration. Okay, so that's going to be the first equation. Then, if we look at what's happening with M1 and draw a free body diagram for M1, then we have the normal force going up, and we have the weight force going down, but we also have the tension pulling it to the right, and that's what's making it move. Right? So the sum of the forces in the y direction for block 1 would be equal to the normal force and the weight force for the first block, which equals 0, because it's not moving up and down on the ledge. It's just moving to the right. So this doesn't tell us any new information, but it does tell us that N equals the weight force. When you plug in the directions, we see that N minus Fg is equal to 0, or that N equals Fg. So the normal force, in this case, as we know, since it's a flat surface, is equal to the mass of the first block times the gravitational acceleration. But the most important thing is what it tells us for the x direction. The sum of the forces in the x direction for block 1, the only force that's there is the tension. And Newton's second law tells us that the sum of those forces equals that block's mass times its acceleration. So that tension is equal to M1 times A. If I plug in the directions, that still means that the tension is equal to positive M1 times A. Okay. So tension equals M1 times A. Tension minus M2G equals minus M2A. Look, I can plug that T into here. And so I have M1 times A minus M2 times G is equal to minus M2 times A. Okay. And now I can solve for what the acceleration of these two blocks are in terms of their masses. Because I know M1, I know M2, and I know G. I mean, well, I can figure out what M1 and M2 are if I'm given their masses, which in the problem we did in class we were given their masses. Well, I can also write it in terms of it. So I'll bring this over here, bring that over there by using algebra. So we have m1a plus m2a is equal to m2g. And then factor out an a from both of these, so that a times m1 plus m2 is equal to m2g. And then m2g divided by this is going to give you your acceleration. So the final actual equation that you would be writing then is that the acceleration is equal to m2g over m1 plus m2. So the number is the same for both mass 1 and mass 2, but the directions are different, because for mass 1, the acceleration is in the positive x direction, and for mass 2 it's in the negative y direction. But the number, the magnitude, is going to be the same. So, and the reason why is because they're connected by the tension, which, by the rope, and the rope has the same tension at all points of it, because of these ideal ropes that we're using in our arguments here. Okay. So these are some methods to use when analyzing things using Newton's laws. Thinking about the behavior of the object, the MA, okay, and what forces are contributing to that behavior. So the sum of those forces equals the behavior. There's the cause and there's the effect. The cause being the forces, the effect being the acceleration the object experiences. And you have to make sure that you keep those separate and realize what is what. So in these free body diagrams, you never draw the MA, you never draw the effect. You only draw the causes. Okay? And so we'll be talking about this a bit more next class and bring in the idea of friction.